grade 12. So welcome back to another Matthew Day channel. So I'm saying grade 12 because this is a new chapter, or rather a new topic into your syllabus, calculus, right? Welcome to the world of calculus, right? So this is a fun and easy topic, right? It's it's like easy but challenging at the same time, but it will be easy when you do like some examples. You will see that the questions, they come every year. You will see the same questions over and over, so meaning you cannot get this topic wrong, right? You have to master this topic. When you go to university, like if you're doing engineering, then calculus will be a major topic, right? Like when you're doing the math, right? When you're doing mathematics, as well as if you'll be doing applied maths, calculus is big on applied maths. Welcome to calculus. So basically we'll be looking at the introduction to calculus. So first of all, let us define the limit, right? Because I believe that's where calculus starts, right? So you're gonna define the limit of a function. So I've been saying this for most of the time, right? Like if you look at the last video that we did, when you sketched the exponential function, we said that, well, we have something like we have an exponential, then we have an asymptote, and then we have you have some sort of a graph, right? So what does that mean? Well, it means now in this case we have fx. So you can see, if I say, well, the limit as x approaches negative infinity of this graph here, well, what will be my answer? Well, my answer will be 0. Why? Because as my graph approaches negative infinity, you can see that, well, my x in this case goes to negative infinity. As my graph approaches negative infinity, well, the graph also approaches 0, right? The value of 0, right? So I hope this makes sense, but we'll look at this and explain its purpose, right? You will definitely understand. Well, so basically the way we define a limit is basically this. I hope you have this on your notes. If you do not, please write it down. Well, the limit as x approaches, let's say, a, and then the function fx, which is equal to L, right? Which is equal to L. Well, this is how we define the limit, right? So it reads as follows. Well, the limit as x approaches a of the function fx will give us the value of L, right? I hope that makes sense. So when we say x approaches a, we never consider x to be equal to a, because fx is not defined when x is equal to a, right? It's not defined. The only thing that matters is like what the graph is doing, or rather how the graph is reacting, or rather how f is defined when it reaches a, right? How f is defined when it reaches a. So in that case, you can see that we said the limit, let's say the limit as x approaches negative infinity. How is the graph of f defined at that particular point? Well, we said, or it will be defined when y is equal to 0 in that case, right? So in this case here, this will be my L. Of course, my function is fx, right? My function will be fx, and then in that case x is approaching negative infinity. I hope this makes sense. I'm trying to explain this in a much simpler way. I hope you understand what I am trying to say here. X is not equal to a, but the only thing that matters is what the graph is doing when x approaches a, right? Or rather the whatever value that you put in there, right? Let us look at an example. Let's say x, or let's say fx is equal to, let's say, x squared plus 1, right? Let's say x squared plus 1. Well, if I were to sketch this graph, then I'll have a floating graph like that. I'll have this floating graph here, and then I'll have my y-intercept at 0 and 1. I believe so, yes, at 0 and 1. So now here, let us look at something. Let's take an x value. Let's say 2, right? Let's say 2. A 2 will have 2 squared plus 1, which is equal to 4 plus 1 is 5. Hence a 2 will have 5. Let's look at what the graph is doing, or rather, let's look at what the graph is doing when it approaches a value of 2. So what we're going to do, we'll say, well, what is the limit as x approaches 2 from the negative side, or rather from the left hand side. When you put this negative, it means that the graph is approaching 2 from the negative side, right? From negative side going to 2. And then when we say the limit as x approaches 2, and then we say positive, so that means that the graph is approaching 2 from the positive side. So make sure that you understand that. So let's say the limit as x approaches 2 from the negative side, or rather from the left, you could say, well, of fx, which is x squared plus 1. So what is happening when x approaches when x approaches 2 from the left, right, or rather from the negative side of this function here? Well, let us draw a box. Let's say we have this box here. Let's say we have this box, and let's plug in my input value as well as my independent values, right? So let us plug in all the numbers coming from the left that are very close to 2. Let's say 1 is close to 2. Let's say 1,5. Let's put in 1,99. Let's put in 1,999, and then 1,9999, right? I want you to plug this on a calculator and check what values that you get. Well, when you put in 1 there, we'll get 2. When you put in 1,5, let's see, 1,5 squared plus 1, well, you get 3,25. And then when we get when we put 1,99, we'll get 4.9601. Then when you put 999, let's see, we're gonna get 4.996, and then of course you'll get 4.999 right? So you can see what is happening. So as my x approaches 2 from the left or from the negative side, well, what is happening to my y? Well, my y is also approaching what is the highest value that what is the highest value here? Well, if you round this off, this is a very close number to 2. This is very close to 2. So if I round this to the nearest whole number, that means that I'll get 5. So that means that the limit as x approaches 2 from the left, then we get 5, right? And then similarly from the right. So you're gonna say well, the limit as x approaches 2 from the right of the function x squared plus 1, what do we get? Well, we're gonna draw the same box. We're gonna draw the same box here. Gonna draw the same box, my input and then my dependent. So you're gonna have from the left, from when x approaches 2 from the right, meaning from this side here, while we have 3, we have 2 comma 9, we have 2 comma 0 0 1, we have 2 comma 0 0 0 1, then you have 2 comma 0 0 0 0 1, right? So when you put 3 there, what do we get? Well, we get 9 plus 1, that is 10. And then when you put 2 comma 9, you should get 9 comma something, right? Because that's very close to 2. So let's say 2 comma 9 squared plus 1. Yep, that's 9 comma 4 1. Then we put 2 comma 0 0 1, and then we get 5 comma 0 0 4. That's 0 0 4. And if you put more zeros there, you get 5 comma 0 0 0 4, and then of course you get 5 comma 0 0 0 0 4. So in this case, again, if you round this off to the nearest whole number, that means that you get a value of 5. So we call this a two-sided limit, right? Because as x approaches 2 from the left, we get 5, as well as when as 2 approaches x from the right, you also get 5. So this is called the two-sided limit, right? I hope this makes sense. So algebraically, they'll give you something like this on your exam: the limit as x approaches 2 of x squared plus 1. Then they want the answer. So basically what you do is you put in the value of 2, you put in this value of 2 in place of x, as easy as that, plus 1, and hence 2 squared is 4, and then plus 1, that's 4 plus 4, 4 plus 1, that is 5. As easy as that, right? So finding the limit shouldn't be the hardest thing right? This should be the easiest thing. This should be easy. So this is what you should expect when dealing with limits. Of course, you won't get these kind of this is very easy, this is basic. I was just trying to explain the limit, but this is basic. So all you have to do is just substitute the value of x, or rather you should substitute this value there, and then you'll get your answer, your final answer, which is 5. So this is only 1 mark or 2. So this should be easy, right? Okay, so now let us look at the laws, right? Everything has laws, right? And if you do not attain, or if you do not respect the laws, then you'll go to jail, right? So that is you have to respect all the laws of mathematics, right? So make sure that you respect the laws of the mathematics, otherwise you understand. So let's look at the first one. Well, the first law is when we have the limit as x approaches a of the function fx plus gx. So now we call this the limit of the sum, right? The limit of sum, a limit of a sum, right? So when we get something like this, well, we could say this is the limit as x approaches a of fx plus the limit as x approaches a of gx, right? So take this as some sort of a multiplication. When we have x plus 2, well, you bring this inside, right? So meaning I have x squared plus 2x, right? Take it as like that. So take it as like that, so meaning I can distribute the limit inside, and both the fx and gx will both get that limit as x approaches a, right? So similarly with the subtraction, when you subtract similarly with the subtraction, come on, so let me just remove this. Okay, similarly when you subtract, right, okay, it's cool. Okay, similarly when you subtract, you will have the limit as x approaches a of fx minus gx. You should get the same answer here. Limit as x approaches a of fx minus the limit as x approaches a of gx, right? So that's a second limit, and this is our limit of difference, right? So the limit of difference, and then law 3 is basically when we multiply by a constant, right? So let's say the limit as x approaches a of let's say k fx. So k in that case is my limit, or rather I mean k in that case is my constant, so meaning I can take k outside and then say k times the limit as x approaches a fx, right? I hope this makes sense. K limit x approaches a of fx. Okay, so this is my constant, the limit of constant multiple, right? Whenever you have a constant, you can take it outside, right, and then do the limit or do a limit of the function. Okay, so let's look at number 4, right? So number 4 is basically the limit of power, right? When we say, well, the limit as x approaches a of the function fx raised to the power n, right, where n of course is an integer. So we can say, well, here let's say you have the limit as x approaches a times fx raised to the power n. So you can put everything in one bracket. And then 5 is the same when you have the limit as x approaches a of the root n fx, right? You can put everything in one root, and then these are all the laws that one should know. Not very important, but again they are important, so that you do not make any mistakes, or rather create your own rules and laws that do not make sense, right? So make sure that you know these laws. They are very crucial to understand. They are not that important, but they are important at the same time. So make sure that you understand, or rather you know these laws by head. Yeah, and that's it for the limit. These are only the basics, or rather the introduction to calculus. So this is the only thing when dealing with limits. We will look at more examples. We'll look at examples on the limit of on another video, but now for now I want you guys to just write the basics first, understand what a limit is before you jump into conclusion, right? Understand what the limit, and yeah, and memorize these laws, rather not memorize but understand the laws, or as they are very crucial to know. Yeah, and